quite a long time ago, I bought this very nice Quarry Hunslet on eBay. 7mm scale, very, very nicely built body, brass job, very pretty indeed. And the gauge was 16.5. Now I actually model in 14mm gauge, and moreover there were problems with the chassis. This is the original chassis, and one of the problems is the worm actually protruded below rail level, which means it can't go over point work without the worm hitting the point, and it really didn't run very well. Now you can see, just looking at this plan view, that it's sort of a fairly complicated chassis. It's got an inner chassis which actually has the wheel bearings and Rumford type wheels and extended axles, and then edged rods and in fact etched cranks with crank pins and all the rest, which you have to quarter by hand and all the rest. So one way or another, it's not necessarily an easy build to get right. Added to which, if you look at that, the gear is off-centre from the worm. It's a black plastic worm, which is fine, but the gear is off-centre to it because you can't centre this particular gear to the worm because it won't move sideways. There isn't room. Now, gears should always be lined up properly with the worm in order to work properly. So there are fundamental problems with this chassis and the motor and gear that are used. Now, rather than spend too much time messing about with this, because it would mean I would have to strip it right down, which is a lot of work, I thought I would build myself another chassis completely, 14mm gauge, which as I say is what I work in, so it's actually scale, and this is the chassis which I now have. This is all made from nickel silver, mostly 1mm thick nickel silver, and you can see I'm actually using working outside frames, so there are no dummy inside frames, and I can do this easily because I'm not using the Rumford type wheel sets. The wheels, actually, the rims are off 00 wagon wheels, and I turned up blank wheel centres on my lathe. There are no spokes on this one, so I just turned up blanks on my lathe. Actually, next time, for the fun of it, I might try printing some wheel centres and see how that works. The axle is just a piece of 2mm bar, plain all the way through, and the cranks are brass. They're actually milled out of 1.5mm brass with 2mm holes for the axle. I wonder if I can zoom in without losing any definition. We'll see. It's probably about as far as I can go. Lost focus, sorry about that. So it's a plain axle, and everything on this I actually CNC'd, because I can, on my Stepcraft mill. Now, before I had a Stepcraft mill, I would have just marked it out and cut it out with a piercing saw, which is the old jeweller's way of doing it, and it's the standard modelling way of doing it. It would have taken me longer and possibly not quite as accurate. It would have involved more filing, but I have done chassis by hand many times in the past, perfectly successfully. The joy of CNC milling is that it's quicker, it is undoubtedly more accurate, and of course it's repeatable, because once you set it up, once you create the program, you have it, and effectively, if you want another one, you can just press the button again and get another one. So that's the joy of CNC work. So it's a luxury I have. Most people don't have it. If you like, it's a priority for me. So the end result is this chassis, which is markedly simpler than this one. But because it's simpler, it's more accurate in many ways, and it works better, and it's more suited to my means. Now, of course, I do a lot of my small locos radio controlled, and this is going to be no exception. You can see how small this is. It's I think it's about 40 mil between the axle centres, and 40 mil that way and 40 mil that way. So it's quite a small loco. And my favourite motor for radio control work is this. Now, these are no longer available, sadly. It's nominally 3.7 volts, and it's a K20 gear motor. And at 3.7 volts, it's got an output speed of 90 RPM. Now, on the shaft, I have mounted a mod 0.3, that's the size of it, bevel gear. And that is secured on there with Devcon epoxy resin very carefully. And this little gem, very small, very efficient, and that is actually going to fit within the chassis frames, whoops, and it's going to mount just in there like that, driving the axle very neatly and invisibly like that. So a very nice, very easy way of doing it, and that'll give me lovely slow running speeds and a good yard speed as well. So that's going to be a real pleasure, to say the least. Conrods, coupling rods, they're all milled as well, as indeed was the crosshead. That was quite nice to draw up and do, and these cylinder end covers are also milled on the Stepcraft. I have made these by hand as well. On other models I've used cast white metal ones as well. I make bearings for these. Now, these are conventional rectangular flanged bearing blocks, just like real locos have, and they run in a rectangular slot in the frame. I've left them a bit loose. I want the front one a bit loose so it'll adapt itself to the track. At the moment, the back one is also a bit loose, although I may have to put a dab of something on to stop that from moving at all, so the gear stays properly in mesh. We'll see. We have a very representative inside motion, which we can see through the frames there, which is why we've done that. So a simple but effective handmade chassis for that. And the idea behind that, as I say, is the motor will sit in there nicely. It needs a radio receiver. That is the radio receiver. It's an RX41-22 from Deltang, manufactured by Deltang, actually got from Micron radio control. And we also need another couple of bits and pieces. We need an on-off switch there, and this coil of wire there is actually a resettable fuse, so that should there be a short or anything like that, we don't cause the battery to overload and have a fire or anything. And we have this little charging socket, which is a 1.25 is it JST or something? I can't remember, but also available from Micron radio control. So those are the other bits that we'll need to wire into this little combination. The switch and the socket I will find a home for somewhere in this region, again completely hidden. And then the last thing we need is a battery. Now I have to hand this LiPo battery. This is a 450 milliamp battery. I do like a little bit more. I like about 650, which I know will last at least a day of exhibition work. There's a number up here. This one says 802030. This actually denotes the size of the thing. The 80 is the thickness. This is an 8mm thick battery. So 80. If it was 75, the first two numbers, it would be 7.5. If it was 4 or 40, it would be a 4mm thick battery. So usually, not always, but usually, the first two figures denote the thickness of the battery, and then the next two, 20, 30, means it's 20mm that way and 30mm that way. So 80, 20, 30 means it's 8mm thick, 20mm by 30mm. It's very useful when you're searching for batteries to fit in a confined space to realise that these numbers actually refer to the battery size. Also on the battery, of course, we have this electronic protection which should prevent over-discharge, which can seriously damage the battery and cause fires. Small batteries like this I only ever charge at 1C. So if this is a 450 milliamp battery, I only charge it at a rate of 400 milliamps per hour charge. And treating a battery like this gently will help ensure you don't have trouble with it. Now this battery, I've taken the body and I've done the awful thing, and I've put a slot in the boiler, and while I was at it I fitted lead in both sides of the boiler and tank to add a little bit of weight. So I've got a nice clean slot in there, and the battery is simply going to sit in that slot, and that'll be absolutely out of view, and the wires will poke through into the firebox. So with the battery happily ensconced in the boiler, the receiver will find a home in action in the firebox. Now, I've never really had any problem with the receiver and its aerial being shielded by either the brass or the white metal of a loco at the ranges at which we operate. So I'm not too worried about its ability to receive signals tucked away within the body. So the only thing that is going to stay fixed with the body is the battery, and I will put a socket on the battery, one of these little sockets, yep, one of those will mount on the battery, and then the chassis, which will carry the receiver, will have one of these plugs, so I can separate the chassis from the body easily and simply unplug the power to the battery. So that makes my maintenance lovely and easy. And also I have on order a slightly bigger battery, slightly more powerful battery, which will increase the duration, because as I've already said, this 450 milliamp battery is a little bit small for my needs, and I can fit a bigger one in. So I've got another battery on order, be fitted with a socket, and that's all that'll stay with the loco body. So my next job is to actually start wiring things up and fit the motor into this void here, and then I can test the chassis under power, which will be nice. It's always nice to see the thing churning over under its own steam, as it were. This is about 4 hours since the last bit of the video, and I've managed to fit the motor and install the electrics. So let's have a look at the end result. The battery is where I said, inside the boiler and saddle tank, and there is the motor. You can see it's a nice cosy fit in there. That is milliput, and that will all be painted black. Single bevel gear drive to the axle. You can just see the battery on that view. I've left it silver for the moment. I shall be painting that black. That there is the charging socket, and next to it is the little on-off switch. So all that will be painted and will disappear visually, and none of it is really visible when it's in place on the track. So just going to lower the camera down a bit so we get a view. Bear with me, and I have a board to put behind it so you can see a little bit better. Right. So we control this with the Deltang TX22. The TX22 has a selector, so we can program up to 12 locos on this. You can't drive them at once. Well, that's not strictly true. You can set them all going but you then have to come off and drive the next one, so you can end up in absolute chaos. Much better to drive one at a time. These are separate channel functions, which I confess I don't bother using. Bind button, on-off switch, and inertia. The inertia is very good. Just have a play. We'll just go forward. This is natural control, as it were. Accelerating. Just trying to keep it in view. Incidentally, just so you know, that is flat out with this little motor, which, when you consider a small layout, is quite fast enough. Mainline, not so, but a small layout, that's fine. Now then, if I set the inertia, I can spin that like that, and then to 0, very much like DCC, and you can vary the amount of inertia you give it. So that's quite a nice function on the TX22. So there will be a teeny bit of weathering. Oops, so I'm running this thing off the edge. A teeny bit of weathering on this loco, and coupling blocks fitting, and a driver to go on. But fundamentally, that is this loco completed. It's a very nice little loco, and it'll be a welcome addition to the fleet on Denton Brook and the subsequent layout, which will, I hope, be a harbour layout. But I'm very pleased with this combination of control and motor. And as I say, once I've put the bigger battery in, I expect this to do at least a full day's exhibition. The Bagnall, which has a 650 milliampere battery, certainly exceeds a full day's use on Denton Brook. So there's a 650 milliampere hour battery going in this one, and the hardware is exactly the same. It's the same receiver, it's the same motor, it's the same gear train. So there is no reason why it shouldn't do exactly the same. So there you have it, a very nice little Quarry Hunslet, radio controlled. Nothing particularly complicated about it, but a very pleasing addition to the fleet, and a nice, small, fetching little loco it is. I hope it's of some use. Everything apart from the motor gear box you can get from Micron. There are other suppliers. Micron has done me very well over the years. I have no connection with the company at all, other than being a customer. But I get all my stuff from there. eBay do a lot of gear motors, sadly not this particular one anymore, but I have found a way of let's say, rebuilding gear motors with different motor and gearbox combinations to suit our needs, and you'll find videos of those elsewhere amongst the collection of videos I've done if you're interested. But I run all mine on dedicated 3.7 volt gear motors, and this gives me the long duration and the nice slow speeds, which makes for realistic operation. If I had any secrets or any tricks, I would say that was it. So enjoy. Thank you.